Hi, we're Jonathan, Braxton, Allison, and James, and we'll be exploring automatic predicate inlining for the Viper Intermediate Verification Language. We'll give a brief overview of Viper, introduce the idea of predicates, talk about our research question and proposed solution, show you what we've done so far, and hopefully we'll have time for questions. So let's talk about Viper. Viper is an architecture for verification tools and prototypes, but it's also its own verification language. That's where most of our work will be in. Some common uses of Viper are to verify sequential and concurrent programs and mutable state. It basically acts as a mid-layer between a high-level front-end in a common programming language and a low-level back-end in Z3. So here's a sample Viper file. Here we have a field declaration, a method signature, a precondition, a postcondition, and a method body. Now let's talk about predicates. These are two methods in Viper that verify some work with tuples. Notice here that we have code duplication in the form of identical preconditions for make tuple and increment tuple. Just like how we can encapsulate duplicated code for reuse in programming languages, Viper enables the encapsulation and reuse of preconditions in the form of predicates. The unfold statement effectively inlines the predicate at runtime, while the fold predicate performs the inverse operation. It's important to note that predicates can be recursive, or even mutually recursive. So what's our research question? A lot of Viper code is auto-generated. This means that there could be a lot of redundant code that a human developer could detect and remove. The unfold statement required by a predicate is an operation that changes the program state. This is potentially a lot of work that's performed at runtime. So we want to ask, how do inline predicates impact the performance of Viper? We're now going to explore automatic predicate inlining. We plan to extend the Viper language with an inline keyword. This will direct predicates to be automatically inlined when possible during code generation before runtime. Here we show an example of what automatic predicate inlining would achieve. We see that the predicate in the precondition is replaced with its body. This effectively removes the need for fold and unfold statements in the body, leaving less work to be performed at runtime. We'll also have to deal with inlining recursive and mutually recursive predicates. We have a few options for tackling this problem. We could trust the programmer, but that's generally not a great idea. We could inline recursive predicates only once, or we could detect cycles and produce a warning. Eventually, we'd like to get to automatic predicate inlining, meaning the developer does not need to use the inline keyword for inlining to occur, but this would be something automatically done at code generation time. This would require us to be able to detect recursive cycles. In order to validate our work, we plan to use industrial benchmarks provided by Professor Alex Summers, who is part of the original Viper project. We plan to use two versions of Viper on the benchmarks, one that uses automatic predicate inlining and the standard version. So what have we done so far? We've decided on a language construct for inlining. We have a working proof of concept that performs simple inlining of all predicates, and we're able to detect recursive cycles. Next, we'll have to extend the parser with the inline keyword, extend our proof of concept to inline predicates based on the existence of the keyword, and run benchmarks. As a stretch goal, we plan to merge with the upstream Viper project. This brings us to the end of our presentation, and we'll now be taking questions if there are any. Thank you.